Next slide, composition of matter. So, the tiniest, the smallest units of matter are called atoms. They are unique building blocks for each element. Let's remember the difference between atoms and elements. Imagine there is a pile of rice on the table in your kitchen. If you sit on the table and if you are asked a question what it is, you will answer it's rice. But if you take 1 grain of rice, that would be a tiny building unit what rice is made of. So in this case, the whole pile of rice on the table would be an element, and 1 tiny grain would be an atom. So if oxygen is an element, then 1 tiny atom of oxygen would be an atom. So that's the structure of the atom. In the center there is a nucleus which is made of positively charged protons and neutral neutrons, tiny particles. Around them there will be moving particles, negatively charged, called electrons. Major elements of the human body would be oxygen, carbon, hydrogen, and nitrogen. Together, they make about 96% of our body mass. That is a table 2.2 in your book showing major elements in our body. For all of those elements, you need to know their name, their symbol. So if you read in your book N, you need to know it's for nitrogen. If you see S, that's for sulfur. So here is a list of major elements: oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. Molecules and compounds. Most atoms combine together using chemical bonds to form molecules and compounds. Molecule is 2 or more identical atoms bonded together. Like 2 atoms of hydrogen make a molecule of hydrogen, or 2 atoms of oxygen make a molecule of oxygen. Compound, it's when 2 or more different kinds of atoms bonded together, like right here C6H12O6. So that is a complex molecule which is made complex compound which is made of 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. In a lot of textbooks, compounds like that are often called molecules too, so don't be surprised. And I highly recommend you to memorize the chemical formula of this one. It's a glucose. So C6H12 and O6, it's a glucose. A bond, it's a weak or strong electrical attraction that holds atoms together. Next slide, mixtures. Most matter exists as mixtures of different types, for example, mixture of water and different particles. So usually 2, sometimes more components are physically intermixed. There are 3 types of mixtures: solutions, colloids, and suspensions. Solutions. When solid particles are very tiny and generally you cannot see them. What does it mean? Take a glass of water, pull a teaspoonful of salt there and mix. Salt will disappear. Now you have a salt solution. Colloid. When particles are larger and you can see them. For example, water would be a colloid. You can see it, milk would be a colloid. When you look at milk, you see it's not transparent. You can see that color, yellowish whitish color, and that would be solute particles of fat and proteins. Finally, suspension. When solid particles are very large, settle out and may scatter light. If you imagine that we mix water with oil, that would be your example of suspension. Usually they do not mix well. Chemical bonds now. There are three types of chemical bonds: ionic, covalent, and hydrogen. Covalent right here, large font, because they are the strongest chemical bonds. Ionic are medium strength bonds, and hydrogen bonds are the weakest ones. We are starting from medium strength ionic bonds. That is an atom of sodium, and that is an atom of chloride. And you see what happens with them. Those particles moving around them, electrons, sometimes they can move from one atom to another. Because electrons are negatively charged, when the whole atom is neutral, when negatively charged electron leaves it to another atom, this one becomes positively charged. It will be called cation right now. Cation, it's an atom that lost one or more electrons. Another atom right here accepted an electron, and because before it was neutral, it accepted one negatively charged electron, now it's a negative ion, and we call it an ion. And because in nature opposite charges attract like magnets, so attraction of a positively charged anion and negatively charged cation causes ionic bond.